Hello everyone, today we talk about machine guns. For our contemporary warfare series that we are widening, these thematic videos are useful, if anything, to lay the foundations for better understanding of lots of tactical, doctrinal aspects that today we will investigate, starting from one consideration. Because in these videos we have to be so basic but to the point as it gets. That is to say, imagine in today's warfare, like having the possibility of a single soldier on a regular basis wielding the firepower of a whole platoon, and realizing that this was exactly the situation in the 19th century when the division of a swift-firing automatic weapon finally materialized, after, by the way, centuries of attempts that, of course, were not aimed, as we'll understand now, to fully achieve this, because they didn't even realize at this point, as it will be clear now, either what potential really laid in such technology. In fact, its full capacity remained unrecognized. Right? It literally required World War I to reveal the machine gun's true role. Today, we will naturally touch on many topics. I decided to shrink the immense subject of machine guns to essentially, light machine guns, mostly from an infantry perspective. This allows us to make also some other points regarding, as you have just understood now, like certain issues that we have, for example, discussed in a video about how trench warfare really happened, meaning how did they get there, and what did they expect? As we explained in that video, it wasn't even because of, shelling or machine guns that they got to that point. It's really the broader political, even before industrial or, demographic power of major countries. They're creating a pretty long and broad stalemate that, however, was consuming enormous quantities of manpower and material into it, so it wasn't strategically irrelevant or foolish or something that simply did not make sense, as some people still oddly believe. So focusing a bit on technology, realizing that, however, technology does not make, and we'll see now many examples of this, the actual 50 plus 1%, no, it never even comes close to that, even when you consider technology broadly meant, not just machine guns, separated from artillery, of course, which is at least even more intuitive. As a medievalist, it's even more interesting to start from the roots of the machine gun concept, or at least the quest for a firearm that could supplant numerous marksmen by delivering an immense rate of fire. It literally began alongside the advent of black powder, right, as soon as firearms were actually introduced in European warfare, right? We tend to underestimate how quickly, technologies are actually invented, and very often how they soon expand as long as there is a viable context for it. Explosive shells were already there as soon as gunpowder was introduced, rockets, idem, etc. Naturally, this is valid also for this sort of multi-projectile, simultaneous shooters, so to say, that were naturally not machine guns, but that conceptually, embryonally, contained that weapon. Historical records first mention multi-shot weapons in 1339, when England's King Edward III carried ribot cannon into France amid the 100 Years' War initial phases. These contraptions featured clusters of arquebuses or light cannon barrels linked to a single ignition point, enabling them to discharge all at once, which is interesting because, again, it's just a sort of burst at the end of the day, and not even of actual effect, shots being fired from within the same barrel, but just multiple single barrels shooting at the same time. Now, the immediate tactical advantage of a device that could focus intense firepower on a target in mere moments was obvious. in this sense. Yet it was just as apparent that this multi-barrel setup fell short of perfection, relegating it to a minor role on the battlefield. Right? We recently talked about different types of late medieval artillery. The main purpose of such weaponry was, positioning it in front of a gate or something if enemy stormed, and like shooting this projectiles at once, right? Not just one big one, which was still, however, an option, but sort of a more complicated one to, for example, to employ, like in terms of just maneuverability, etc. Is kind of obvious, right? Here, the problem is not much this type of design or concept. Is just the limited role of early artillery in medieval warfare, right? We've seen it in many videos. We will make others on the topic. Crafting, instead, an effective repeating firearm demanded solutions to three core issues. First of all, a metallurgical hurdle involving the construction of barrels durable enough to endure the swift deterioration and heat from continuous firing. A mechanical difficulty tied to the robustness and accuracy of the weapon's operating components, and the sluggish, awkward process of muzzle loading with flintlock ignited black powder cartridges. Naturally, you have to wait, predictably enough, the Industrial Revolution for having all the components with the right, in the right quantity, availability, and replaceability, so to say, and also uniformity, and what really took in order to create not just a repeating firearm that could be, again, employed to some degree of effectiveness on a battlefield. But this is not to say that Europeans hadn't previously tried to achieve this between the contemporary and the Middle Ages. In fact, during the Renaissance, the Germans and the Italians, the most technologically advanced peoples in Europe, had made some experiment. The concept of a revolving cylinder, for example, where multiple chambers rotate to align with a single barrel for sequential firing, began to emerge already in the 16th century. Historical records suggest early prototypes or ideas for such devices. For example, a 1580s German manuscript, the Codex Vindobonensis, illustrates a wheel-lock pistol with a rudimentary revolving mechanism, possibly inspired by crossbow repeating designs like the Chinese Chu Ko Nun that we will see at some point. The Germans were pretty advanced in wheel-lock pistol technology. The Reiter and the caracol tactic were really mastered by German horsemen. Another precursor to repeating firearms was the pepper box, a multi-barreled handgun where each barrel had its own charge and could be rotated to fire sequentially. And while pepper boxes are typically associated with the 18th and 19th centuries, crude versions may have existed earlier. A 16th century Italian design attributed to gunsmiths in the 1590s, so you see more or less in the same aforementioned German example, reportedly featured a cluster of barrels that could be manually rotated. Again, the reasons why certain technologies do not kick in immediately into employment is the lack of adequate doctrine, but even more of a general sort of moral and material background that politically, societally, that does not simply allow the science and economy available to introduce this weapon in an effective manner. So, of course, the technology existed. It just like steam engine existed since antiquity. But you really do need, like more or less, this example, the 18th century for having some very concrete applications. And why? Because you need to mechanize, because there is a much greater surplus than before. It's not random that it started mostly in countries like England or France, etc. So we will look surely at these aspects of the history of technology and economics as well that are very fascinating, but that here we give just for assumed, for granted, given that we have discussed them at some point in other videos. Now, getting into more sort of serious attempts, the early innovations, we can really look at James Buckle and Jacob Perkins, both Englishmen. In 1718, Buckle, an English lawyer, secured a patent for a clever and strikingly forward-thinking invention, the so-called defense gun. Right, so consider this age. Right, these are the times from Rule Britannia. Right, it's that early. This guy was born in the late 17th century, and this defense gun resembled an oversized revolver, fixed atop a tripod turned by hand with a crank, and able to fire 9 rounds per minute, even under harsh weather conditions. Now, these people's backgrounds are also interesting because, again, Buckle was 1667, 1724. He didn't even live long enough after that. Was an English lawyer and notary in London with no formal engineering nor military training. Right, a civilian with a flair for mechanics that operated in early 18th century Britain amid growing colonial and maritime needs. Driven by practicality and profit, Buckle aimed to solve the problem of slow reloading firearms, particularly for defending British ships and outposts against pirates or rivals. His legal and business acumen pushed him to patent, and you understand how this has practically nothing to do with technology per se, and market the defense gun, as we've seen in 1718, reflecting a desire to capitalize on a tactical need with a novel, rapid-fire solution. Roughly 100 years later, Jacob Perkins, another Englishman, devised a highly unique automatic weapon powered by high-pressure steam. Essentially consisted of a basic tube fitted with a valve to release steam. Projectiles loaded into a vertical magazine were propelled at a rate of 1 per second with sufficient force to penetrate a 6mm iron sheet from 30 meters away. With no explosive action involved, the barrel experienced minimal wear and required no replacement. Interestingly enough, France acquired one such weapon, though it never saw battlefield use because, of course, steam weapons are not really that practicable. But again, this guy's background is also interesting. Perkins, 1766-1849, was actually an American inventor from Massachusetts originally, but a British-based inventor, was a self-taught mechanic and engineer. Starting as a goldsmith, he amassed patents in nail-making, engraving, and steam technology, relocating, in fact, to London in 1819 to exploit his innovations during the Industrial Revolution. And fascinated by steam's potential, Perkins sought to outstrip gunpowder-based firearms with a cleaner, continuous-firing alternative. Steam-powered, dated as we've seen circa 1825, was less about military need and more about showcasing his engineering prowess. That's the point I was making before. There are many inventions that are created at some point, like the automatic doors of Alexandria that opened with steam power, but what was the practicality of it? Or were they even conceived for being eventually employed in a large scale? But not really. And it's not even about at the time. If in ancient times they had switched from slavery to the industrial, why? Why would they have had to do that? Right? Didn't make any sense. Not as a form momentous, but literally as in the moment. We would ever venture into something like that? With which knowledge? With what kind of evidence that something that would have still taken millennia to be accomplished would have eventually worked? These are ridiculous ideas. In any case, going back to Perkins, driven by a lifelong passion for bold cross-disciplinary invention and recognition in Britain's inventing hub, was a valuable reference in today's video. But we have really to get to the two brilliant breakthroughs in machine gun technology that really brought to its introduction in the military on a relevant scale. Not until the mid-19th century, in fact, did advancements in industry, science, and technology surmount the barriers that had previously blocked the development of a genuine machine gun. Right, the times were right, conditions were ideal, prompting a surge of inventive minds to devise a variety of designs. In my series about the Funkriege, I started with some introductory videos, including the one essentially here of the previous generations that really shows you the explosion in scientific discoveries, technological inventions, and more, including Napoleonic Wars, the same Clausewitzian theory of the art of war. Now, among this sort of variety of designs formulated by military engineers, but also, as we've seen, by lots of civilians, because that's really how it would more normally occur, the mechanical machine gun conceived in 1861 by American innovator Richard Jordan Gatling stood out as the most renowned and effective. Right? Though it boasted impressive capabilities and design principles still relevant today, this crank-operated weapon failed to gain broad acceptance. The background is interesting to observe here as well, because Gatling had no military background, no training, no combat experience, and no formal role in any armed forces. Right? So his contribution, as we'll see now, to military technology stemmed entirely from his civilian career as an inventor, leveraging his mechanical skills, although also observations of the American Civil War's demands. Right? But it's important to observe how his lack of military experience did not hinder his creation of one of history's most influential weapons. Rather, it highlights how an outsider's perspective could reshape warfare. Again, Richard Jordan Gatling and his iconic crank mechanism. He was born in 1818. He died in 1903, so just in the last century. And he could have confined himself to just his medical career. That's how he had begun. But instead, he poured his energy into inventing, especially in the realm of farming equipment. His true claim to fame, however, came through his work on repeating firearms. So just also an eccentric field of his interest. After studying existing designs, Gatling tackled the issue of barrel overheating, resulting from the repeated blasts of a fast-firing gun that, as we've seen, was one of the major issues up to this point in history, preventing such weapons to be even, ideated, considering this technological limit up to this point. And Gatling's answer was a 6-barrel system where each barrel fired in sequence. So obviously allowing for more heat distribution splitting among the various barrels, achieving with the gun a total rate of 600 rounds per minute, each individual barrel handling thus just 100 rounds and allowing ample cooling time, naturally for the time standards. Patented in November 1862, the inaugural Gatling machine gun featured 6 barrels arranged around a central shaft within a manually rotated frame. Its ammo consisted of small steel cylinders, each capped with a percussion tip and holding a cartridge complete with charge and bullet. These were fed from a hopper, dropping one by one into the firing chamber for detonation. Gatling pitched his creation to the Union government, aiming to, quote, aid in quelling the rebellion, but his North Carolina origins, a Confederate state, stirred suspicion among Northern military leaders, thwarting widespread acceptance. Only General Benjamin Butler embraced it, personally funding the purchase of 12 units at $1,000 apiece, and deploying them effectively in the Petersburg siege, that at some point we will surely see. You understand how costly they actually were. This would be the case for all these early machine guns before World War I, except on the eve of it, things had changed a bit. And even though the various countries, the high commands, the same military engineers and officers were well aware, by the way, this is where it gets interesting, of the potential machine gun fire. Doctrine, which is a more complex thing, and it has to do with how this is going to act in concert with all the rest, had not really identified the importance of these guns. That would be immediately identified, as a matter of fact, in the first, immediately, like at least in the way they could and would be employed in incredibly sophisticated and effective trench warfare, say, doctrine, so to say, but that up to that shortly before had not really been conceived in the, or at least had the effects of these guns had not really been projected, had not been tested. It could have not been otherwise to that scale of warfare that World War I turned out to be. In fact, unlike, this is always the same problem. It's a political one. It's not much one of military incompetence and just even pursuit of doctrinal issues, because before wars are fought, well, you can't really say what was going to happen. It's part of course, the unpredictability of warfare, but you can't know, in fact, how a factor like technology, as we've seen, especially in this individual element, can play out as a whole, considering it's in fact not anything like it's just, blue or red, 50-50, whatever. It's just one small thing in an immense system, and you can't really foresee how the system is going to employ that factor, going to integrate that factor. This is a very important aspect. Now, the American Civil War is a thing on its own. As we've seen here, there are some doubts and resistance about the adoption of the gun. In any case, the U.S. Civil War was really groundbreaking in terms of military technological innovation. We will see it better as we're going to continue the American Civil War introductory series, so to say. Now, the initial machine gun to be officially adopted by a major military force was the Refi Mitrailleuse, which is a beautiful name, by the way, because it means mitrailleuse, right? And it's female, right? So you really want to marry a woman called the Mitrailleuse who can pierce your heart at 75 rounds per minute. The name of the Mitrailleuse, the Refi, in fact, was after its creator, General Jean-Baptiste Verchères de Refi. Here, the background was actually an important military one. Refi's military background was that of an engineer and innovator, not quite a combat veteran, but still within the military field. His career progressed through technical education, the École Polytechnique and Metz, steady artillery service, and high-level ordnance roles under Napoleon III. His legacy lies in the mitrailleuse and breech-loading cannons, products of his mechanical genius, rather than battlefield experience, cementing his place as a pivotal figure in 19th century French artillery development. Integrated into Napoleon III's French army in the mid-60s, the mitrailleuse, that we're going to make a distinct video on it because it's a fantastic weapon, and we will explain better why, evolved from a Belgian prototype, more a refined version of the medieval Ribaud Canon than a proper machine gun. It bore the official title of Canon à balles, that is to say, a bullets cannon, right, that unleashed rapid bursts. Around this time, a misconception about the tactical deployment of machine guns already took root, right, persisting until, as we were saying, World War I. These devices were, in fact, undeniably bulky, as we've seen with the Gatling one as well, affixed to artillery carriages that pushed their weight near a ton, rendering them largely immobile, right? In the French military, this took shape for the first time historically on a large scale. As a result, the French, though valuing their combat potential, didn't see the mitrailleuse as a groundbreaking weapon necessitating a fresh tactical strategy, a new doctrine, right? Its designation as canon à balles led to its placement within batteries alongside 3 conventional cannons assigned to shield them from nearby threats, an arrangement that diminished the artillery unit's strength while curbing the rapid-fire weapons utility. Right? During the Franco-Prussian War of 1870, French artillery units faltered in long-range exchanges with adversaries. Yet the Mitrailleuse repeatedly proved itself deadly prowess in close quarters fighting. This is particularly interesting. It had also an impressive range, as a matter of fact. We're going just to discuss the technicalities in another video, but there were some instances which Prussian infantry was cut to pieces in monstrous ways, mostly as they were caught at medium range in the open, right under this weapon that really could cause this carnage, but that, as also the outcome of the Franco-Prussian War demonstrates, does not make technology decisive in war. In fact, the French were overall much more advanced than the Germans during the Franco-Prussian War, and also, for example, in rifle barrels technology, probably handguns, and yet the Germans had a better doctrine, and at some point also simpler technology but more effective ones, proving how it's really the use that you make, not much the performance per se, that from a strictly material point of view that makes the difference. The subsequent leap forward in machine gun history came courtesy of US inventor Hiram Maxim, who meticulously examined existing designs and prototypes to craft a superior original model. His epiphany struck while test-firing a Springfield rifle, much like Newton's apple, and the background was in this case particularly important. In fact, Hiram Maxim had no military background, no service, no formal training in arms or strategy. His genius lay in his self-taught engineering skills developed through civilian trades and inventions like lighting systems and even mousetraps. His Maxim gun, born from a recoil epiphany, transformed warfare not because of military experience but despite its absence, showcasing how a mechanically minded outsider could outpace traditional arms development. His legacy endures in every automatic weapon that followed. Maxim felt the jarring recoil and pondered how to harness that energy more productively. This insight birthed the first fully automatic machine gun, which recycled the recoil gas energy that would otherwise go to waste. This ingenious innovation transformed the weapon, producing a single-barrel design that independently loaded and expelled cartridge cases. Unlike mechanical predecessors, Maxim's creation operated autonomously, firing until its ammo ran dry, requiring only that the gunner hold the trigger. No tedious crank turning as with the Gatling or similar models was needed. Right. This naturally afforded the operator far greater mastery over the weapon. Capable of unleashing up to 10 rounds per second, the Maxim's ammo demands alarmed potential buyers due to the expense and logistical burden involved. Its water cooling mechanism, another drawback, raised its weight to approximately 40-50 kilos. Early on, the Maxim saw action in colonial settings, decisively overpowering tribal foes, not just through the heavy casualties it caused, but especially the terror it instilled in opponents. Remember that, as we've seen also in the videos about linear tactics, platoon fires, that's what really matters in the same interest of time, the same amount of shots fired, is how concentrated these are, right? Naturally here, it's a different matter because you increase just the amount of bullets as well as if you want to fire for a longer time, given this increased rate. But primarily, it's not, in fact, at this point, the just even the devastation you can create just in destroying the enemy that is, at this point, in fact, starting to spread out. Like also, Western armies, as you know, are abandoning properly the thick formation, the full battlefield, right? And so they must open up. But it's all what this new tactics entails. and the fact that we can't stress enough here not just the rate of fire, but also precision, range, really renders the battlefield a much more randomly dangerous place. And that does strategically affect the engagements themselves. The Anglo-Boer War 1899-1902 marked the first instance of both sides employing machine guns, followed by the Russo-Japanese War 1904-1905, where the Japanese wielded French Hotchkiss models, and the Russians used Maxims paired with the pioneering light machine guns, the Madsen 1902. Just a word for these two because they would become, as you know, particularly important in the period. The Hotchkiss machine gun, specifically the model 1914, evolved from designs by American expatriate Benjamin B. Hotchkiss, who founded Hotchkiss at Sea in France. After his death in 1885, his team, led by Laurence Benet and Henri Mercier, perfected a gas-operated air-cooled gun by 1897. Adopted by the French Army in 1914, it used 7.92 per 57mm Mauser or 80mm Lebel rounds, fed by 24 30-round metal strips or belts with a rate of 450-600 rounds per minute. At 12 kilos plus tripod, its rugged simplicity and quick-range barrel made it a reliable workhorse in World War I. Speaking of the Madsen instead, 1902, the world's first true light machine gun, originating in Denmark from designs dating back to the 1880s, Danish artillery officer Wilhelm Hermann Oluf Madsen, alongside engineer Julius A. Rasmussen and designer Theodor Schuboy, developed a recoil-operated magazine-fed firearm, building on the experimental Danish self-loading rifle model 1888. They refined the concept through the 90s of the 19th century at Dansk Rifle Syndicat. Madsen, as war minister, pushed its adoption, and the Royal Danish Army accepted it in 1902 as the Regelgewehr model 1903, chambered in 8 per 58mm. It's lightweight, about 9 kilos, and portability set it really apart. Japan's triumph on Russia resonated globally, prompting military leaders everywhere to scrutinize the war for lessons ahead of the anticipated major European war. Their conclusions reinforced the belief that little had fundamentally shifted since the Franco-Prussian War. Russia's loss was blamed solely on the Tsarist army's weaknesses, cementing the machine gun's reputation as a defensive tool unfit for the era's offensive-driven military philosophies. In part, this was true at large, but in relative terms, the relevance of the machine gun was probably underestimated. And again, you have to properly look at how poorly Russian forces performed, not to see that it was a much bigger deal, of course, of a point of broader political, military, social fragility that is much more important than what kind of machine guns the two sides had used in the war. In any case, at this point, strategists argued that the machine gun firepower wasn't pivotal, as modern bolt-action rifles with 5 to 10 round magazines already supplied ample output, by the way. They held that triumph or failure hinged on the valor of soldiers in the fray, which in fact was correct, and the steadfast determination of their commanders to propel them forward, which in here we could say was really missing part of the point, or at least had not anticipated what the importance of eventually positional warfare, also due, but not decisively due to machine guns. That, yes, we're also seeing, in fact, still in that mostly defensive fashion, which, as you understand, was not really a broadly wrong concept, right? So that its transitioning of the machine gun from defense to attack is a gradual path. So to say, think about the Stoßtruppen, or again, lighter machine guns that you would employ, in fact, during attacks as well. That's a shift, but this is not to say that this would be enough against, by the way, other machine gun fire among the rest to unlock trench warfare, which in fact did not happen during World War I. At least, again, everything is contextual, but on the Western Front and in many ways, at least at large in others, the same stalemate had been produced. So here, again, we follow just one part because we've seen here just the first machine guns and their employment. Again, we're skipping heavy machine guns, we're skipping sort of other, for example, anti-aerial employment, all this stuff. So there are many automatic weapons at this point coming around, and although we can't really understand them without the others, was pointing out this is just like a big concert. It's all part of a much bigger system. At large, we can't cover everything in a single video, and so we'll talk doctrine, also including about World War I and before, by the way, as after in other videos. We have also to pass in post-World War I doctrine, like Bewegungskrieg, tank warfare, and more, because that is really crucial. So when the Great War erupted, almost every machine gun used by the warring nations traced its lineage directly or indirectly back to the Maxim, except in Italy, which opted for its own creation, the Fiat Ravelli Model 1914. The Fiat Ravelli Model 1914 was Italy's first machine gun, by the way, designed by Abel Bethel Ravelli in the early 1900s and produced by Fiat. Adopted in 1914, it was a water-cooled, belt-fed weapon chambered in 6.5 per 52 millimeters Carcano. Ravelli adapted the gas-operated mechanism from his earlier Villar Perosa submachine gun, scaling it up for rifle cartridges. Weighing 17 kilos plus 23 kilos tripod, it fired at 400-500 rounds per minute. Though innovative, its complex 50-round magazine, a grid of 10 per 5 cartridges, and sensitivity to dirt made it less reliable in trench warfare. Regardless of origin, these firearms delivered a formidable rate of fire, as we've seen, averaging 400 to 500 rounds per minute, with enhancements in dependability and reductions in weight. Accompanying them were the earliest light machine guns, manageable by a lone soldier, including the previously noted Madsen, the French Hotchkiss, and the Schwerpunkt, the German MG 0.8/15, and the American Bar. So as far as the Schwerpunkt is concerned, officially the CSRG Model 1915 was this French light machine gun designed by Louis Chauchat, Pierre Sauter, and Ribeyrolles, with production overseen by Gladiator, hence CSRG. Adopted in 1915, it was chambered in 8 millimeters level and weighed 9 kilos. A long recoil magazine fed 20 rounds design, it fired at 240-300 rounds per minute. Cheap to produce, it armed French and American troops in World War I, but its open magazine and poor reliability in mud due to loose tolerances and flimsy construction earned it a bad reputation, especially the .30.06 US version. The MG 08/15 was a lighter adaptation of the Maxim MG 08, Germany's standard heavy machine gun from 1892, modified in 1915 by Spandau Arsenal engineers. It retained the water-cooled, belt-fed, recoil-operated design in 7.92 per 57 millimeters Mauser, but reduced weight to 18 kilos from 26 by slimming the water jacket and adding a bipod. Firing at 450-500 rounds per minute, it became the most common German machine gun by 1917, bridging the gap between heavy and portable firepower, though still requiring a crew for optimal use. The Browning automatic rifle, or BAR, designed by John Moses Browning in 1917, was a gas-operated, air-cooled light machine gun for the U.S. Army, chambered in .30 to 06 Springfield. It weighed from 7 to 9 kilos and fired 20-round magazines at 650 rounds per minute, introduced late in World War I in 1918. Specifically, it excelled as a squad automatic weapon due to its portability and reliability. Browning, a prolific firearms inventor, crafted it to provide mobile firepower, and it's so extensive use through World War II, famously enough, and beyond. At first, in World War I, armies showed little appreciation for machine guns, right, as reflected in their scant allocation of just 2 per battalion. We've seen similar issues, for example, in the Grubeval reform, as opposed to the previous Valierses. There are always this kind of resistances, even from those that are going actually to be, say, favored by the same doctrine and the new weaponry. However, within weeks of the war's onset, these weapons showcase, in fact, immediately their extraordinary potential, deployed largely as artillery pieces, still often left exposed and solitary. They were susceptible to enemy infantry fire, granted, yet they yielded remarkable outcomes. On occasion, a solitary machine gun could annihilate an entire battalion of foot soldiers. So, as we've seen and explained very thoroughly in other videos, it's not like World War I was caused by, one guy, a machine gun pinning down 100 people and preventing breakthroughs. That had nothing to do with that. If you look at the major battles between offensive and defensive, most of those were taken out by artillery. But in general, the scale of losses is the same. So this multiplier effect, because of one single technology, did not exist anyway. The advent of trench warfare, spurred directly by the impact of machine guns, among other factors, did, however, dramatically alter the soldier-to-weapon ratio. Right, the most striking shift occurred within German divisions, where the proportion leapt from 1 machine gun per 480 riflemen in 1914 to 18 by 1917, with their numbers swelling from an original 24 to 358, comprising 142 top-tier heavy MG 08s and 216 lighter MG 08/15s. Finally, the machine gun earned a fitting role in offensive maneuvers. It assisted in the gradual dynamization of World War I tactics. Germany's Stoßtruppen, that we were mentioning before, experts in storming enemy lines, wielded the lighter variants as steam weapons and critical support points for each assault, a tactic that endures to this day, as a matter of fact. Meanwhile, among the Entente forces, light machine guns anchored the feu de marche tactics, where a row of gunners fired while advancing to pin down the enemy with suppressive volleys, aiding grenadiers and shock troops who trailed behind and surged ahead to strike the trenches directly. I talked about this in that video, how to storm a trench, right? So you understand here what's the feu de marche, so walking fire, practically is. Shosha bars would have fired continuously while advancing. The goal was to suppress enemy trenches, allowing grenadiers and assault troops to close in. Gunners typically fired from the hip or shoulder, maintaining a steady stream of bullets, for example 240 to 600 rounds per minute, depending on the weapon, to pin down defenders, a technique honed by French and American forces, in particular in 1917-1918. Now, we understand that the direction here is the one of the all-purpose firearm, in a sense, or at least a type of weapon that would be adaptable to practically any kind of tactical situation, or that simply you could not do without anymore. There is the concept of a campaigning weapon. We will talk about, and better especially, about machine gun fire in small unit tactics and sort of broader engagements as well. We look now at after World War I. and so the interwar period and World War II especially. In fact, following the Second Reich's downfall, that we have documented also in the video about the Freikorps and their understanding of trench warfare and how this could be adapted, for example, to essentially to even urban warfare that had not constituted a great part of World War I for that matter. But the peace treaty's terms set in Versailles prohibited the formidable MG-08 from the arsenal allowed to the Weimar Republic, right? And yet in Germany, preparations were already underway for one of the modern era's most influential tactical innovations. We'll make lots of videos about this. We're talking the so-called Blitzkrieg, better termed the Bewegungskrieg, ushering in the last major chapter in the machine gun's development. And here things, again, get a bit more complex because we should talk about tank warfare and beyond. In any case, sticking to, say, a machine gun perspective, the groundbreaking German military philosophy of the Bewegungskrieg called for a fresh perspective on the weapon's tactical application, marking the first time a machine gun was tailored to precise battlefield requirements, right? Not just some kind of additional firepower that eventually would have more or less to sort out from a unit perspective, or even, of course, with specific issues, but that were not part of a much more complex combined armed tactics other than, bombardment and assault, infiltration tactics, etc. The resulting concept, termed Einheit Maschinengewehr, that is to say universal machine gun, so this unitary all-purpose, right, machine gun, is now recognized as the general-purpose machine gun, in fact. And instead of crafting one heavy model for prolonged fire and another for squad-level automatic use, the vision was a single weapon, right, versatile enough for both tasks and beyond. Mounted on a tripod, it could act as a heavy machine gun, unleashing relentless barrages. Fitted with a bipod, it served as a standard squad automatic firearm. And after an early vision, the MG-34, deemed too costly and time-consuming to manufacture, the Wehrmacht unveiled the MG-42 in spring 1942, Maschinengewehr 42. This battlefield newcomer was a masterpiece, as you know, in military engineering, mechanically flawless, sturdy, simple to maintain, and most notably capable of a fearsome firing rate of 1,200 to 1,500 rounds per minute. This is insane, right? This exceptional rate stemmed from its recoil-operated roller-locked mechanism designed by Werner Gruner in 1942, using a lightweight bolt, 650 grams, in a short recoil stroke. It cycled rapidly, aided by a muzzle booster that increased bolt speed. Chambered in 7.92 per 77 usual millimeters Mauser, its belt-fed system and quick-change barrel sustained fire, achieving 20 to 25 rounds per second, right? So the MG-34, as we've seen, had been introduced, in fact, in 1934, had laid the groundwork as the first general-purpose machine gun. Designed by Rheinmetall, it fired 850 rounds per minute with a versatile air-cooled bipod/tripod setup. Its accomplishments included proving the general-purpose machine gun concept portable yet potent, but its complexity and cost, needing, as we said before, precise machining, spurred the simpler, faster MG-42. And the resulting torrent of bullets emitted a unique sound that I think all military history, enthusiasts of amateurs instantly recognize, reminiscent of ripping cloth or a buzzing circle or so, some sort, quickly became a source of dread for adversaries. Like, though its accuracy lagged behind some other weapons, its sheer density of fire deterred any attempt to move in the open. Right, this moment marked the zenith of machine guns evolution. In the years that followed, in fact, it would be honed further, but its core essence remained unmatched since the MG42 groundbreak. The aforementioned Werner Gruner, by the way, 1904-1995, just to understand the times and the people, an engineer at Metall and Metall- und Lachwarenfabrik, Johannes Grossfuss, was among those commissioned by the Wehrmacht to develop a successor to the MG34. That was, after all, a fine weapon. We know it. It had neatly performed. We've seen it in the video about the Dieppe. We will talk about the Eastern Front soon at some point as well. But again, it was too expensive, complex to mass produce, though. New to machine gun design, Gruner excelled in mass production techniques like metal stamping and pressing. He sacrificed 6 weeks of vacation to enroll in an army machine gunner training program, gaining direct insight into the real-world application. So you understand that here the two worlds met. And conversations with soldiers, in fact, revealed that, what they valued most in such a weapon. Back at his drafting table, Gruner blended the finest features of prior models with contemporary industrial methods and the practical knowledge he'd acquired, giving the rise to the MG42. In 1942, this machine gun became a blueprint for nearly every military of the time and influenced subsequent automatic weapons. For example, Italy's Beretta MG42/59. We will talk later about some successor to that. And there is a bit, in fact, of also of mythology about certain things. For example, about the Sturmgewehr 44, what the relations with the AK-47, all this kind of aspects, etc. But that we will talk about in another video, if anything. What can we say? Again, we do not talk about heavy machine guns, broader doctrinal, tactical issues. They would be very interesting to do, but again, we have to make one thing at a time in being compact, right? Effective. Today we injected a bit of, food for thought, hopefully, in the fray. But I would talk about 3 standout designs that you cannot really miss when making a video about, this sense, more modern machine guns. In fact, as we were just saying, the remarkable attributes of the German MG42 spurred modern militaries to embrace the general-purpose machine gun concept as well. In the decades following World War II, the purpose and traits of this type of weapon have been consistently validated. Right, current machine guns share strong similarities, in fact, all rooted in gas-operated mechanics akin to the Maxim, differing only in weight, caliber, and firing speed. We can argue that rifles themselves have not dramatically really changed from the beginnings of the 20th century. In raw scale, essential performance, of course, lots of things change, but in practice, like if you think about range, if you think about precision, like things have, of course, refined. They have technically sophisticated in ways that also added to, by the way, the cost of weapons, which is something you have always to in fact connect with the proper contextual background. That's why, I don't know, PKs are more out there in more savage situations, whereas, I don't know, the M240 is something more advanced. But this is, again, yet another aspect. In any case, certain models have distinguished themselves through superior efficiency and performance, and it's essentially ones we're already described here, earning widespread adoption. Again, also for dynamics like massive exports. Think about the Cold War, the end of the Soviet Union, and so on. In fact, these include, first of all, like the Russo-Soviet Pulemyot Kalashnikova, or better known as PK, a family of weapons notable for their modest weight, around 9 kilos, paired with exceptional durability and reliability, however. That again, they're not necessarily like shooting performance just per se, but something you can rely on. That is very important, of course, it can make the difference between life and death. So everything has its own context. Nothing is per se just better or worse than another without that background. And designed by Mikhail Kalashnikov's team, this Soviet general-purpose machine gun in 2.62 per 54 millimeters are weighed 9 kilos, fires 650, 720 rounds per minute, and excels with its gas-operated reliability, quick change barrel, and ruggedness in harsh conditions, serving over 50 countries. Then you have the Belgian FN MAG, the most prevalent choice among NATO forces, known as the M240 in the US military, with an impressive firing rate reaching up to 1,000 rounds per minute. And that's really insane, right? From Fabrique Nationale, Belgium, designed by Ernest Verviers, this 2.62 per 51 millimeters NATO general-purpose machine gun weighs from 11 to 13 kilos. So it's actually, needless to say, it requires lots of physique. And fires 650 to 1,000 rounds per minute. So as you understand here, of course, almost double what would be a World War I machine gun. I mean, in this sense, yes, a great development, but not just an overwhelming one, right? Compared to the earlier, say, types in the gradual refinement that sort of accelerated and stopped to an optimum that was just refined later. The FN is gas-operated, belt-fed design, adaptable, bipod tripod vehicle mounts, and durable, making it NATO's standard, notably as the US, in fact, M240. Finally, important mention, the German Eckler & Koch MG5, unique for incorporating mechanisms borrowed from its lighter counterpart, the MG4 machine gun. Right, the MG5 is again 7.62 per 50 millimeters NATO, 10 kilos, 640 to 800 rounds per minute. Its lightweight polymer build, reliability, and modern ergonomics replaces the MG3, excelling in versatility and ease of use. Having said this, again, this is a pretty small, compact video about sort of early machine gun development, probably the concept behind it, and again, at some point, especially, this is since the beginning, since the second half of the 19th century. Of course, things are more complicated than mere performance. Again, and that's sort of the least interesting to an extent aspect of machine gun history. However, this is just for making a broader point, having made a video in which we at least address the main issues of this path, how things came into being, and just given that minimal literacy on the topic that, as you've seen, again, you can make longer and longer videos. They're going to be cursory, right? I could make a video, like there are lots of videos about machine guns out there, including real, operations with them. That there are quite big channels showing you how to shoot stuff, with those, and those are admittedly interesting. I will not shy away from. I don't have time for watching them, but I will not deny that there isn't something liberatory saying, the idea of shooting with a machine gun. Who wouldn't really like to do that? Looks like, a military setting, minus the risk of getting killed yourself. However, And there are lots of videos about, look at this, the performance, which one is better, which one is what. Look at how it's mounted, it's dismounted, how I feel it in my hand, on my shoulders, etc. That's fine. Of course, I'm a military historian, and say I dare call myself an expert in the art of war, or at least that's what I mostly do also in my professional life, so I would say it's fitting. And so I have to provide with a general background, especially, at least this is the thing that interests me the most. It's the overarching narrative, like how and why would the machine gun come by, right? Is it, if you don't think outside the box of other relative references, you cannot appreciate also the absolute value of the machine gun, because yes, everything is, as we just said today, circumstantial, contextual. But it doesn't mean that that a bullet from this stuff does not bear like an absolute relevance. So that there is an even bigger picture that doesn't stop to the mechanical side of the story. Would be just the equivalent of talking, I don't know, as many channels really do, about, look at how a 13th century armor looked like, look, I'm wearing it, that's so cool, and not knowing literally nothing about 13th century tactics that are, or the art of war in general, that are much broader than whatever, I don't know, a chainmail was made, or how you feel it when you have it on you. So that's, probably having people picturing the radical scale in difference and importance between the two things in a radically concrete sense. That's the most important thing, not just in saying, well, male is male, so that's solid. How have we become so materialistic? And, collective training, moral forces, battle tactics, there are, not important. Like, those are actually the most important things. And so even if today, again, we especially sort of narrowed the focus down to just the machine, essentially the light machine gun, as it would come, in fact, to be identified and in fact further characterized, I think that adding this tacit to Schwerpunkt's tapestry here is quite relevant. I've been doing recently lots of videos about World War I. I also created a playlist finally. So we're heading in the right direction. I ended up really making lots of World War I videos in the last year. We should make more about World War II and other contemporary warfare, telling the truth. But I'm glad because we're finally starting to talk about this in a sort of more concrete way. We're starting to bridge the various gaps that were left open by just by the way we chose topics. And I hope that this is interesting because, as I said in a recent video reflection on the channel, the general purpose of Schwerpunkt is to talk about the art of war, broadly meant, and so not merely just this or that topic, and it shouldn't be just Middle Ages, regardless of my obvious bias. It should be opening to different avenues, opening up a major highway at some point for a sort of encyclopedia of medieval war, in fact, you see the bias there, of the history of the art of war more specifically. Always been about the art of war, but not just the medieval one, right? So this is what I really care about. However, for today, I stop it here. I just hope that you enjoyed this video. If you did, please share it. Otherwise, leave a like or subscribe to my channel if you're interested in my upcoming content. As always, I thank you heartily for listening to me. I wish you a nice time and see you next time. Bye.